Hello guys, it's Automation Minister here. This is my second video. Let's go. Today I will be talking a bit about PLC programming languages, standard related to it, standard data types. I'll show examples of every language and explain a bit about them. This will not be programming tutorial, but instead introduction to PLC programming languages and some other languages used in automation. I'll talk about what I know and why, and what you should know in my opinion. IEC 61131 version 3 standard is standard for programmable logic controllers. To be precise, it's for the PLC programming languages, and it was published on 1993 by IEC. Standard has 5 languages, which I set in best to worst order. In my opinion, structured text ST is best. Reason behind it is that it kind of feels limitless to me compared to other languages like FBD or something. It might be worse in some specific occasions, but if you need to do some complicated things, then ST would be your choice. And in my opinion, it's very good for general use as well. I mainly code with ST on daily basis. We have function block diagram, FBD. It's graphical programming language. Typically, it uses logical gates like AND, NO, OR gates, different counters, and RS flip-flops. FBD is very intuitive for someone who knows basic electronics. It's easy to learn and use, and fast to some degree. You fast to learn, not super fast as a program, but yeah. You can even use custom function blocks that have ST written on them. That's useful in the situation when you have very complicated program. You might want to make a custom ST function block. Third is ladder diagram, LD, which is very intuitive as well. It kind of reminds me of some relay schematics, and that's why it is easy to understand for most of the people. As far as I know, it's very popular and kind of de facto in process automation and factories. But on BMS side, where I work, it's not commonly used, at least in Finland. Then we have instruction list, IL, which is second text-based language there is. It reminds me of assembly language. Some of you will understand why when you see the example. I didn't learn anything about instruction list in school. I actually studied it on my own time, and in work I did some bug fixing. Then we have sequential function chart, SFC. It's used on industrial automation, but not on BMS, as far as I know. I don't have very much to say about it. I haven't studied it. I should someday, but time will show if I do. Some of the controllers could be programmed with something like C or C++, which is somewhat used in stuff like room controllers, air supply units, etc. Then there are like Arduino based systems like Controlino. I checked on Controlino's website and it states that, quote, Controlino is an industry-grade PLC with open source software, fully compatible with Arduino. Something worth mentioning is CodeSys. I will put link to video description about it. But yeah, CodeSys is German license-free programming tool. It has text editor for both structured text and instruction list programming, and it has graphical editor for all three standardized programming languages, LD, FBD, and SFC. On top of that, it has graphical editor for CFC, continuous function chart. It's somewhat similar to function block diagram programming. Languages used on Finland. Well, on BMS side, we use mainly like structured text and FBD. On process side, they use ladder, SFC, and FBD. Data types are defined in standard. I put some of the data types here, but I didn't have enough space for all of them, so you should check them out on internet. There you can see like bool, int, real time, other data types like char, string, and some generic data types like any int and any string. Then there are user-defined data types, enumerated and arrays, etc. Here is example of ST and IL. On the left side I made program. I'll explain it to you step by step. So on top we have variable declaration. There we have alarm variable, which is integer, magnet valve, which is integer as well. Here I give alarm a value 1, and then I have if else statement for it. So if alarm is 1, which means on, then magnet valve will be 1, which means on. Else magnet valve will be 0, which means off. And then I end the if else statement. Here is instruction list example. It's actually as the ST code is translated to instruction list code, which is translated by IAC compiler. That happens at least with OpenPCS, which is the software I'm using. Some of you might see why it looks like assembly. Then we have function block diagram, FBD. If you are familiar with logical gates, then you understand this, but I'll explain this to you anyways. So we have OR gate, which works like if you have one or both inputs are 1, then the output will be 1. We have two 1s, so output will be 1 here. Then second one, we have one input 1, which means output will be 1. Doesn't matter if we have 1 0 because we have 1 1. So both inputs here are 1. We have AND gate, and it basically means that if input 1 and input 2 will be 1, the output will be 1. That's pretty much it. Then we have ladder diagram, LD. Now some of you see why it reminds me of relay schematics. It kind of looks a lot like that. So we have start button, stop button, and motor is controlled by them. This is most simple one of the most simple ones you can make. You can study ladder by yourself on internet if you want, and I think I'll make some videos about it as well. But you should definitely learn it. Then we have sequential function chart, SFC. It works like this. So we have first step, do something. So let's say we have like make cup of water. Then when it has done with the making of water cup, it checks the step condition. So we could have like, if we have 1 cup of water, continue to step 2. Then on the step 2, it can have like make cup of coffee. And when it's done with it, it continues to step condition, which could be like if you have 1 cup of water and 1 cup of coffee, continue to step 3. And step 3 could be like make a cup of water and coffee both. So then when it's done with it, we go to step condition 3, which could be like if we have 2 cups of water and 2 cups of coffee, continue. What I know and why. Well, in the school I studied ladder diagram and FBD. On the free time I started studying ST because I think that it's essential for people to know how to use ST because it has less limitations than all of other languages. And if you get to very complicated programs, it's beneficial to know ST. I think I'll study more instruction list someday, not today. Then SFC, I don't think that I'll actually ever study it. Maybe if I move to process automation, then I'll pick it up. But now it doesn't seem to be important for me. What should you learn? Well, easiest way to say it is everything, but it kind of depends. If you go to industrial automation, then you should probably know ladder diagram, FBD and SFC. And I still say that you should learn ST as well. But if you go for BMS, I think you can do with structured text and function block diagrams. But yeah, it's up to you. But in all the situations, ST is very good to pick up, in my opinion. And some of the people like to get to know PLC programming by starting to code FBD or ladder because they are very easy to understand and like you can learn faster than ST. And they are very intuitive for most of the people that know basic electronics or something. Yeah, thanks for watching. Leave feedback. I'm open to new ideas as well. I'm planning to make a video about Modbus on near future to be precise. If you have any video suggestions, you can leave them in the comment section. Yeah, thanks. Bye.